Hello everyone. In the last videos we were discussing uh, points from the first unit of basic electrical and electronics engineering, that is fundamentals of electricity. From this video, in a couple of videos from this, we'll be discussing uh, the points from the second unit, that is electrostatics of basic electrical and electronics engineering from electronics and instrumentation engineering. Okay, now we'll move on with the we'll first get to know what are the learning objectives of this video. The learning objectives of this video are shown on the screen. The first one will discuss about what is electric charge, later what is meant by electric lines of force, and then what is meant by electric flux density, and finally we'll conclude this video by knowing what is meant by Coulombs law of electrostatics. Okay, now we'll move on with the presentation. Let us start our class with the first point, that is electrical charge. Before that, we need to know three basic points, that is the study of electricity is divided into three different branches, that is electrostatics, electromagnetism and electric current. First one is electrostatics. It is nothing but the study of the force that acts between 2 point charges. The study of the force that acts between point charges. The second is electromagnetism. It is a study of the forces that act on the charges that are in motion. Those electrostatic is nothing but the force between the point charges. Electromagnetism is nothing but the forces that act on the charges which are in motion. That is moving charges. The forces that act on the moving charges will be is called as electromagnetism. The third one is electric current. It is a study of the form of energy that is associated with the flow of charge. Okay, these points have to be kept in mind while studying electrostatics. Okay, now we'll move on with the what is meant by electric charge. Electric charge, the physical properties of a matter which allows it to experience a special kind of force when kept under the influence of electromagnetic field is called as electric charge. The physical properties of any matter which allows it to experience a special kind of force when kept under the influence of magnetic field, that is electromagnetic field, is called as electric charge. The movement of electric charge are responsible for the production of one of the many types of electrical energies, one of the many kind of energies which we call it as electrical energy. So this movement of electrical charge will give us energy, and that energy is called as electrical energy. In general, electric charge, in simple terms, electric charge is defined as the property of subatomic particles that causes it to experience a force when placed in an electromagnetic field. The electric charge is measured using Coulomb. 1 Coulomb is the quantity of charge that is transferred in 1 second. That is, in a time of 1 second, how much quantity of charge is being transferred is measured with a unit called as Coulomb. This Coulomb is a unit for electrical charge. Coulomb can be represented as Q is equal to I into T, where Q is the electrical charge and I is the electrical current, T is the time. So with this relation, Q Q is equal to I into T makes it clear that the charge Q is directly proportional to the electric current. The electrical charge is proportional to the electrical current. That is, how much amount of electrical current is being generated in the given time, will that much amount of electrical charge will be produced. So this point is to be kept in mind, that the Q, electrical charge Q is equal to I into T. I repeat, electrical charge is nothing but any matter which allows it to experience a special kind of force when it is kept under an electromagnetic field is called as electrical charge. Unit is Coulomb and Q is equal to I into T. And coming to the types of electrical charges, there are two types of electrical charges are there. The first charge, these points we already know, but the continuity sake I am explaining here. In general, there are two types of electrical charges. The first one is positive charge, the second one is negative charge. Neutral charge do not refer to the third type of charge, but we say it as a region between the positive and the negative charges. So neutral charge, here we don't consider it as a special kind of or the third category of charge, but it is a region between the positive and the negative charges. Suppose if there are identical positive and negative charges and their sum will be 0. This means that these positive and negative charges are now electrically neutral. That is, when equal number of positive and negative charges are present, and for each positive charge, each negative charge will get balanced, so the sum will be equal, then that condition we say it as electrically neutral. Okay. Next, coming to the electrical lines of force. The second point is electrical lines of force. Now we will discuss what is meant by electrical lines of force. First, suppose if a free to move unit positive charge, that is the positive charge which is ready to move, is placed in an electrical field, it will experience a force due to which the unit positive charge will move along a particular path. Okay, that unit positive charge will move along a particular path. This unit positive charge can be placed at different positions in the field, and the unit positive charge will follow different paths when it is placed in different positions. The paths along which this unit positive charge will move due to the electrostatic force in the field is called as electric lines of force. That is, electrical lines of force is nothing but the unit positive charge when placed in an electrostatic field, the path that this unit positive charge is taking or the path in which the unit positive charge will move is called as electric lines of force. Okay. To understand it clearly, I'll try to give a clear view using simple diagrams. So in this slide we can see 6 different diagrams. I'll let you know what all these are. We consider the direction of electric lines of force as a direction of movement of unit positive charge in the field. We represent the direction of lines of force with arrowheads. This point you have to keep it in mind. In general, the direction of lines of force are represented with arrowhead. Let us take a negative charge. Let us take a negative charge, this charge. Let us take a negative charge of minus q coulombs. Also, let us place a unit positive charge at a point in the field of charge q. This is a unit positive charge. Let us place this near the charge near the field of charge minus q. According to Coulombs law, the unit positive charge will experience an attraction force towards the center of the said negative charge. So here we can see that there is this unit positive charge because of the Coulombs law, or else according to the Coulombs law, this unit positive charge which is placed near a negative charge or the field of charge will try to move towards the negative charge. If this unit positive charge is free to move, this will move towards the negative charge. Okay, that is in this direction along the straight line joining the center until along the straight line joining the center of the unit charge and the center of the set negative charge. In this diagram we can see that this unit positive charge will be moving towards here in this diagram we can see that this unit positive charge will move towards the charge minus q in a straight line joining the center of the unit positive charge and the center of the negative charge. So we can observe that unit positive charge and the charge minus q are joined at the centers. Okay, the line along which the unit positive charge move towards this negative charge is defined as the electric lines of force. This line, now what we are seeing, or this line is called as electric line of force. If we place this unit positive charge anywhere else in the field, the line of force was created along that new point. Okay, so now let us take a unit positive charge of plus q coulombs. We place a unit charge at a point in the field. Now let us take unit positive charge as it is, but the charge initially we have taken it as minus q. Now we will take it as plus q. And let's see what happens. According to Coulombs law, this unit positive charge will experience a repulsive force. So in this diagram we can see that this positive charge will repel to this positive q. That is, according to Coulombs law, we already know this point, like charges attract and unlike charges repel each other. This is what was mentioned in Coulombs law. As it is a positive charge and the q is also positive, the unit positive charge will move or else will show a repulsive force. Okay, this repulsive force, as a unit positive charge is free to move, that will move away along the straight line joining the center of unit positive charge and the set positive charge. The line along which so we can see here that here in this diagram you can see that this plus q and unit positive charge, as a unit positive charge is now free to move, that will move away from along the straight line joining the center of the unit positive charge and the set positive charge. The line along which the unit positive charge moves away from the set positive charge is called as electric lines of force. Similarly, we place the unit positive charge anywhere else in the field, the line of force will create along the new point. Okay, so previously I have said that when we take unit positive charge and a negative q, the direction will be inwards in a straight line. Both will attract. Whereas in this slide, when we take a positive q and a unit positive charge, the unit positive charge will move away from plus q, that too in the straight direction. Okay, so these lines in which the unit positive charge is moving is nothing but electric lines of force. Okay. Since we can place a unit positive charge at infinite number of points in an electric field, theoretically there will be infinite number of lines of force created in the field of an electric charge. But mathematically, to represent the influence of electrical charge in a field, the total number of force that are coming from an electrical charge is taken as the equal to the value of the electrical charge that is measured in Coulomb. So there will be infinite number of charges present. So the infinite number of electric charge and electric lines of force will be there. But in order to represent all those, it is not possible. So to represent the influence of electric charge in the field, the total number of lines that are coming from the electrical charge is taken as equal to the value of electrical charge that is measured in Coulomb. That means Q Coulomb charge gives Q number of lines of force surrounding it. This is shown in this diagram. So this is in minus Q. So all the unit positive charge will be moving inside towards minus Q. There may be n number of charges, so n number of lines will be represented. But for theoretically, we show it as the number of lines will be equal to the number of coulombs that we represent. Okay. Now let us place one positive charge particle of object plus q coulombs and one negative charge of minus q coulombs side by side as shown in this figure. For example, take this figure. Here what I am taking is that I am taking two charged object. One is 1 plus coulomb and this one is negative charge coulomb of minus q side by side. Let us place a unit positive charge at any point in between these two charged particles. The unit charged particles will experience an attraction force by the negative charged object and a repulsive force by the positive charged object. Due to influence, attraction and repulsion force, the unit positive charge will move along a curved line from the center of plus q charge and the center of minus q charged object. Considering other lines of force, we can draw the electric lines of force like this. Okay, we can draw electric lines of force like this, considering the above said concept. If we take a positive q and a negative q charge. Now let us place two positively charged object plus q coulombs and minus q coulombs side by side like the diagram which is shown below. According to this diagram, when we place two positive charge particles side by side, let us place a unit positive charge at any point in the charged object. So we can place any charged particle, unit charge particle anywhere near this field. What happens is that the unit positive charge will experience a repulsive force by plus q charge on which the unit positive charge is placed. The unit positive charge also experience another repulsive force by near positive charge plus q charge. Due to the influence of these two repulsive forces from both the sides, the unit positive charge will move away from both plus q charges. So here we see a repulsive force from both the sides and the unit positive charge will move away from both plus q charges. So based on this, the electric lines of force between these two positive charges can be drawn like this. Okay. So with this we got to know what is meant by electric lines of force. These electric lines of force are nothing but the path along which the positive unit charge will move due to the electrostatic field is called as electric lines of force. These lines of force can take any direction. based upon the placement of the unit charges. Okay. Next, coming to the properties of electrical lines of force, we can summarize these properties of electric lines of force into some around 11 numbers. We'll discuss all them thoroughly. Okay. So the first property is that each electric lines of force is conceptually imagined. It does not have any physical existence. So all the electric lines of force are just imagined, but they don't have any physical existence. Okay. Second point is the total number of lines that are coming from a charged body is equal to the charge of the body measured in Coulomb. So this point we have already discussed previously. Okay. The third one is each electric lines of force is originated from a positive charge and terminated into negative charge. Okay. This is another important point, like electric lines of force originating from positive charge and terminating to the negative charge. This is third important point. The fourth one is a tangent drawn at any point on the electric lines of force indicates the direction of electric field at that point in the field. Okay. The next one is each electric lines of force comes normally from the surface of the charged body. Next is the electric lines of force can only contract longitudinally. Okay. In horizontal way. The seventh point is electric lines of force can expand laterally. Eighth one is no two electric lines of force cross each other. So that's why when we represent any electric lines of force, we see that none of the lines touch each other. The ninth point is the electric lines of force in same direction repel each other. So this also we have discussed. The 10th point is that electric lines of force in opposite direction attract each other. So these 2 points, like the direction, same direction repel each other, opposite direction attract each other. These 2 points are based on the law called as Coulombs law. The last point is that no lines of force can exist inside a conductor. So these are the points which show the properties of an electric lines of force. So with this I have given you enough data regarding electric lines of force. So initially we were discussing what is meant by electric charge, and later we have moved to electric lines of force, and what are the properties of electric lines of force have been discussed till now. Next we'll move on with the point called as electric flux. So the next point for this video is electric flux. The electric flux is defined as total number of electric lines of force that are coming from a charged body. How that is, till now we have seen what is meant by electric lines of force. This electric flux, what we are discussing now, is nothing but how much amount of or how many electric lines are force are coming from a charged body is represented by a point called as electric flux. So the number of lines that are coming from a charged body is simply called as electric flux. Like magnetic flux, electric flux lines are not always in a closed loop. So in general, magnetic flux of lines are represented in closed loop, whereas in electric flux lines are not always in closed loop. This is because an isolated magnetic north pole or an isolated magnetic south pole do not exist practically. So whenever we give a representation of a magnet, we show it as north pole and south pole in combination. So we don't represent it as an single north pole, single south pole. So at any time if we represent a magnet, we show it with a north and south pole. So an isolated magnet north and south pole are not practically in existence, but an isolated positive charged body and an isolated negative charged body can exist. So that's why magnetic flux is always shown in closed loops. But isolated charge, a positive charge and isolated negative charge can be represented. That is why electric lines of flux are not always in closed loop. Electric flux is denoted by letter psi. We take the measuring unit of flux as the amount of flux that is coming from 1 coulomb of positive electric charge. Okay. We know that the number of lines of force coming from a positive charged body is numerically equal to the charge of the body measured in coulombs. As the flux is the total number of lines of force coming from a total charged body, the unit of flux is also taken as coulomb. So for the electric lines of force, the unit is given as coulombs. Likewise, the same thing we are using coulomb as a unit for electric flux. So if Q is the charge of the body and psi is the electric flux coming from the body, then we can write charge Q will be equal to psi, that is electric flux. That is electric flux will be equal to the charge of the body. Both will be equal. Okay. The next point for discussion is electric flux. Electric flux is nothing but the number of lines that are coming from a positive charged body is called as electric flux. Now we'll discuss what is electric flux density. Electric flux density is defined as the amount of flux electric flux density is defined as the amount of flux passes through a unit surface in the space imagined at the right angles to the direction of electric field. The expression of electric field at a point is given by E. Electric flux density E is equal to Q by 4 pi epsilon naught epsilon r into r square, where Q is the charge of the body by which the field is created and r is the distance of the point from the center of the charged body. We know that, and also we know a point called as Q is equal to psi, which we have discussed previously while discussing electric flux. Q is equal to psi. The above equation can be written as E is equal to psi by 4 pi epsilon naught epsilon r square. That will be equal to epsilon naught epsilon r E is equal to psi by 4 pi r square. This is the expression of flux per unit area, since 4 pi r is the surface area of the imaginary sphere of radius r. This is the flux passing per unit area at a distance r from the center of the charge. This is called as electric flux density at the set point. Generally, we denote this with an English letter D. Therefore, D is equal to epsilon naught epsilon r E. So, the electric flux density D is given as epsilon naught epsilon r E. Epsilon naught is absolute permeability, whereas epsilon r is relative permeability, and E is nothing but the electric field. So the expression for electric flux density D is equal to epsilon naught epsilon r into E. The expression for electric flux is Q is equal to psi. Okay, next, the last point for this presentation is Coulomb's law. Coulomb's law. The magnitude of electrostatic force of attraction or repulsion between the 2 points of charges is directly proportional to the product of the magnitude of the charges, that is Q1 and Q2, and inversely proportional to the square of the distance between them. So Coulomb, according to Coulomb, in this presentation we have already seen one law, that is nothing but positive charges, like charges attract, like charges repel, and unlike charges attract. This law is mentioned by or proposed by Coulomb, and the same person, another law has been mentioned from Coulomb. That law is nothing but Coulomb's law. He has said that the magnitude of electrical force, electrostatic force of attraction or repulsion between the 2 point charges is directly proportional to the product of magnitude of charges and is inversely proportional to the square of distance between them. So based on this statement, we can write that Fe is equal to K into Q1 by Q2 by R square. Fe is equal to K into Q1 Q2 by R square, where Fe is nothing but electric force, Q1 and Q2 are nothing but electric charges, either positive or negative charges we can take. K is nothing but Coulomb's constant, which is given as 8.988 into 10 power 9 Newton meter square by Coulomb square. So this value we can remember that Coulomb's constant K is given by numerical value as 8.988 into 10 power 9 Newton meter square per second Coulomb square, where R is the distance of separation. The like charges usually repel each other and the unlike charges attract each other. The SI unit for Coulomb electric charge is Coulomb and is equal to around some 6.242 into 10 power 18 10 power 18. The value of charge of an electron is equal to minus 1.602 into 10 power minus 19 Coulomb. Coulomb is described as a quantity of charge passing through a cross section of an electrical conductor which carries 1 ampere per second. The symbol used to denote the quantity of electricity is Q, and it is directly calculated with an meter called as electrometer. When the charged particles were produced by rubbing suitable materials, then we were known about the existence of the charges. This experiment we have been I think we have done during our childhood. Like for example, take a comb and rub it on your head and place the comb near the pieces of the small pieces of paper placed on a table. Then you see the comb start to extract the paper pieces. Okay, so this experiment we have I think everyone might have done in their childhood. So according to the Franklin convention, the electric charge present on the comb is a positive charge and the charge that is present on the paper pieces is a negative charge. The comb which attracts paper pieces contain positive charge and any object which repels the comb is negative charged. Okay, so this is all about or this is a simple example or simple demonstration for the Coulomb's law, that is using a simple comb and small pieces of papers, attraction and repulsion characteristics can be easily observed by these two simple properties. Okay, so with this what we got to know is that from Coulomb's law, like charges attracts and unlike charges like charges repel and unlike charges attract, and at the same time these charges the amount of charge F will be equal to electric force will be on these charges F will be equal to Coulomb's constant K into the charges q1 q2 divided by the distance of separation between the charges. So these are the points which have to be kept in mind regarding Coulomb's law. Okay, so with this in this presentation we got to know points like what is meant by electric charge, and before that we have discussed what are the three branches of electricity like electrostatics, electromagnetism and electric current. And later on we have discussed what is meant by electric charge, the unit of electric charge, and what are the different types of electric charges, and what is meant by electric lines of force. And after that I have shown you some diagrams representing some charges q, and taking a unit positive charge I have shown you how these electric lines of force will be generated between a charge q and a unit positive charge, and how electric lines of force have been generated. Along with that we have discussed various properties of electric lines of force. Around we have discussed some around 11 different properties of electric lines of force. Later on we have discussed what is meant by electric flux, and after that we have discussed what is meant by electric flux density, and the expression for electric flux density is also mentioned, like E is equal to Q by 4 pi epsilon naught epsilon r into r square was the expression which we have discussed, and from that we have derived an expression for electric flux density, that is D is equal to epsilon naught epsilon r E. Later on we have discussed a law called as Coulomb's law, which shows the properties, or which shows the characteristics of the charged particles relating to electrostatics. That is the two different properties we have discussed regarding which was proposed by Coulombs. Okay, so with this we got to know some basic fundamentals and regarding electrostatics, and in the next coming videos we'll discuss the other points from the same unit, that is electrostatics and electromagnetism. In that we'll discuss some of the basic laws like Lenz's law, right hand thumb rule law, and other laws which are related to electrostatics will be discussed in the next coming videos. And thank you.